Hello future engineers, here is another video in dynamics, particularly on kinematics of particles. I hope that you will enjoy watching, you will learn from this video, and I hope that your knowledge in dynamics will increase, thereby transforming you, molding you to become better engineering students, and hopefully you will succeed in your chosen engineering field. So here we go. The acceleration of a particle is directly proportional to the square of the time t. When t is 0, the particle is at x equals 24 meters. Knowing that at time t equals 6 seconds, x is 98 meters and the velocity is 18 meters per second, express x and v in terms of t. So we first set up the equation for acceleration, then after that we derive expressions for velocity and acceleration, and we evaluate constants from the boundary conditions given. So we begin with the definition of acceleration here, which is directly proportional to the square of time. So acceleration is a constant k times square of time t squared. Then since acceleration is the derivative of velocity with respect to time, then we substitute acceleration, which is kt squared equals derivative of velocity with respect to time. So that's why by simplification, differential of velocity equals kt squared dt. Then we integrate both sides with constant of proportionality here. So the integral of dv is just v, and the integral of k times t squared over t squared dt is kt cubed over 3. Then we introduce a constant which is c sub 1. So v equals kt cubed over 3 plus c sub 1. We then define the velocity, which is the derivative of x with respect to time, position with respect to time, derivative of position with respect to time. So dx dt is equal to this expression here, kt cubed over 3 plus c sub 1. So simplifying, differential of x equals quantity kt cubed over 3 plus c sub 1 times differential of time t. Then integrating, integral of dx equals the integral of this expression, integral of quantity kt cubed over 3 plus c sub 1 dt. So of course the integral of dx is x, the integral of kt cubed over 3 is kt fourth over 12, then plus c sub 1 t plus another constant c sub 2. So x is kt to the fourth over 12 plus c sub 1 times time plus c sub 2. We then evaluate c sub 2 because when time is 0, x is 24. So 24 equals 0 plus c sub 2. So that means the constant c sub 2 is 24 meters. Then for the other boundary condition, when x is 96 when time is 6 seconds. So 96 into this equation here, and take note that c sub 2 is 24. So 96 equals k times 6 to the fourth over 12 plus c sub 1 times 6 plus 24. 96 minus 24 is 72, and 6 to the fourth over 12 is 100. So 108k plus c sub 1. So 72 equals 100k plus 108k plus 6 c sub 1. Then divide everything by 6. So we have 18k plus c sub 1 equals 12. And we will call this equation 1. Then for the other condition for velocity, for this expression here, velocity is 18 when time is 6. So substitute into this equation here, 18 equals k times 6 cubed over 3 plus c sub 1. simplifying, 18 is equal to 72k plus c sub 1. And let's call this equation 2. So to evaluate k, we have to subtract equation 1 from equation 2. Let's rearrange first. 18 equals 72k plus c sub 1. And we have to subtract this equation 1, which is 12 equals 18k plus c sub 1. So subtracting equation 1 from equation 2, we can eliminate c sub 1 and solve for k. So 18 minus 12 is 6, and 6 is 72. K minus 18, k is 54k. So from here, k is 6 over 54, or 1 over 9 meters per second to the fourth. So that's the value of k. Having found k, we substitute into equation 2 to solve for c sub 1. So 18 equals 72 times 1 over 9 plus c sub 1. 1 over 72 times 1 over 9 is 8. So 18 minus 8 is 10. So c sub 1 is equal to 10 meters per second. Having found this constant, we can now derive the expression for the position x. So x is equal to this. So into this equation, x is equal to k 1 over 9 times t to the fourth over 12 plus c sub 1, which is 10 times t, plus c sub 2, which is 24. So therefore, the formula for x is t to the fourth over 108 plus 10t plus 24. Likewise, for v, which is this formula here, v is k 1 over 9 times t cubed over 3 plus c sub 1, which is equal to 10. So simplifying, d therefore is equal to t cubed over 27 plus 10. So that's it for this problem 11. We proceed to problem 12. So for problem 12, the acceleration of a particle is defined by the relation a equals kt squared, which is the same in problem 11. So part A, knowing that the velocity is negative 8 meters per second when the time t is 0, and v is positive 8 meters per second when the time is 2 seconds, determine the constant k. Then B, write the equations of motion, knowing that also that x is 0 when time is 2 seconds. So we begin with the definition that acceleration is equal to kt squared, and acceleration is derivative of velocity with respect to time, and it is equal to kt squared. So that's why differential of velocity is equal to kt squared differential t. Integrating, integral of dv equals integral of, so k integral of t squared dt. Integral of dv is v, then this is kt cubed over 3, then plus constant c sub 1. Then we evaluate c sub 1 because when time is 0, v is negative 8. So negative 8 equals ck times 0 cubed over 3 plus c sub 1. So c sub 1 is equal to negative 8 meters per second. Then for the second condition, when time is 2, v is 8, so that we can evaluate k. So 8 equals k times 2 cubed over 3 plus c sub 1, which is negative 8. So 8 plus 8 is 16 times 3, 48. 48 divided by 2 cubed, which is also 8. So k is 6 meters per second to the fourth. So having found k, we now have the expression for acceleration, which is kt squared. So it is 6t squared. Then for the velocity, v is kt cubed over 3 plus c sub 1, and c sub 1 is negative 8. So it is equal to 6t cubed over 3. So that's 2t cubed plus negative 8. So v equals 2t cubed minus 8. Then for the position x, v is dx dt. So dx dt is v 2t cubed minus 8. So dx is quantity 2t cubed minus 8 dt. Then integral of dx equals integral of quantity 2t cubed minus 8 dt. So x is equal to t to the fourth over 2 minus 8t plus constant of integration c sub 2. Then for the boundary condition when x is when time is when time is 2, x is 0 here. So 0 equals 2 to the fourth over 2 minus 8 times 2 plus c sub 2. So c sub 2 is 16 minus 8. So c sub 2 is positive 8. That's the value of c sub 2. So therefore, x is t to the fourth over 2 minus 8t plus c sub 2, which is 8. So that's it for this video. I hope that you were able to follow the explanations and the solutions.